And we proved the law of sines before by using SOHCAHTOA with sines. Now we're going to actually use a cosine in the triangle. And so what I want to do is start off by looking at the whole triangle ABC, and I'm going to draw in the height H, which is the same way I started with the law of sines. Nothing is different. This is going to be my side A, this is my side C, and this right here is going to be my side B. But what I want to do is I want to put an X here, and I want to put a B minus X here, because instead of using sines for my equations, I'm actually going to use three equations. One equation is going to involve the Pythagorean theorem on the left side. The other one is the Pythagorean theorem on the right side. And then the third piece is going to be a cosine of angle A. And then I'm going to take those three equations and combine them all into one, and that is going to be my law of cosines. So, for starters, the left triangle is going to be x squared plus h squared equals c squared. And on the right side, it's going to be b minus x quantity squared plus h squared equals a squared. I'm going to go ahead and get rid of my h because I don't want that. This is for a non-right triangle. I'm looking at angles and sides. So when I get rid of the h's, I'm going to solve each of those for h squared. And then I'm going to eliminate the h squared by substituting in, which means you end up with this. Again, eliminating the h squared, they're both equal to it. So you could think about substituting in or saying that they're just the right sides are equal to each other because they're both equal to h squared. At this point, I want to distribute that through. And remember that I'm really talking about parentheses there. I'm talking parentheses because I have to distribute that negative sign all the way through. And remember, it's b minus x times b minus x, so you have the four multiplications. By distributing the negative sign, you end up with something like that. Now, by looking at the left side and the right side, you see that there's an x squared, a negative x squared on both sides. So if I added x squared to both sides, I would actually get rid of those x squares. And the thing that bothers me now is this thing right here, which is this x. X is not part of my main big triangle, and I want to get rid of that x. So I'm just going to go and do a little bit of work off to the side and say my angle A, the cosine of A, is equal to x over c. And now I can solve for x by multiplying both sides by c. It's c times cosine A. And then what I want to do is actually substitute in that for my x. And then I'm going to be pretty much done with the law of cosines. So it's going to be that. Now, the only last thing that we have here, and I know we've done a lot, but the only last thing is just to juggle those terms around and get them on the correct side so it flows a little bit easier. And so what I want to do is solve it for a squared. So I'm going to do a couple things at once here. I'm just going to say a squared, which if I think about that in terms of my right side, is going to be a squared is going to equal, let's see, c squared, right? And then I'm going to add b squared to both sides, plus b squared. And then I'm going to subtract this big term from both sides. And so it's going to be minus 2b c cosine A. And this right here is how we just developed the law of cosines. Now, there are certain cases when you want to use the law of cosines, just like the law of sines. And just as a little reminder, we have law of sines. The cases we said you could use the law of sines are side, side, angle, angle, side, angle, 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 side. Those you can use them. Remember, this is a quiz question, and we said that the one that you can't use for the law of sines is side, 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 or side, angle, side. One of those two is going to be on the test, on the quiz. But for the law of cosines, the two cases where you can use them are going to be side, 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 and side, angle, side, where the angle is in fact included, and we'll do one of those problems in class today. So side, 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 and side, angle, side are the two cases for using the law of cosines. Now, this main equation can be manipulated in certain ways. It's a pattern, and you could solve for it like b squared equals in terms of a and b, and c squared equals in terms of a and b. But if you know the pattern, you can just automatically apply it to the other way, the other letters. So, for example, this is written the same exact way as the Pythagorean theorem. It doesn't matter what the hypotenuse is because this is for non-right triangles. So you can write this any way, but it's like the Pythagorean theorem. But because it's not a right triangle, there is no right angle on the main triangle. You have to subtract a little bit off because it's not accurate. And the piece that you subtract off is 2 times these two sides, B and C, times the cosine of the opposite angle to A. So that's the pattern that you can see. And on the next slide, it's going to give you all 6 ways of writing it. There are 3 like this, but also I solved for cosine A in case you had to solve for an angle. So the next slide is going to show that this is the same pattern as these two. It's not like you have to know all 3 of them. If you understand the first pattern, you hopefully got the other 2. Then what I did, this is to find a side because it's a side squared equals. But to find an angle, often is the case, it will be easier to use cosine A equals whatever's the rest. Now, this is not a different equation than this. These are equivalent. All I did was I said, okay, I'm just going to solve for that cosine A, and when I solve for cosine A, I'm going to get what the right side is. And so in the problems, so you could do it 2 ways. If you wanted to get an angle A, you could say, well, I'm just going to use this equation up here. Or you could say, I'm just going to not deal with the right side at all. I'm just going to deal with the left side, and then I'm going to put in my numbers for here, and then I'm just going to solve that equation for cosine A, and then get my A on that one. So it's not like you have to use the ones on the right. It's just more convenient if you have those provided. Now, the other thing that you know about cosine is that when you use your calculator, you're either going to get an acute angle or obtuse angle, and that is going to be the angle that you're going to get. You're not going to need to consider a second case. It's always one case when you're dealing with the law of cosines. You cannot draw two triangles when you have a side, 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 or a side, angle, side case. That's only one triangle exists. So that's the benefit of using the law of cosines. Now, one other point is when you do use the law of cosines, you want to find the largest angle first. Because if you find the largest angle first, then you're going to know what the obtuse angle is, if it is obtuse. And then you can easily find the other ones by using like the law of sines. So you may have to use the law of cosines in conjunction with the law of sines. I want to do two problems, and then we're going to get to the quiz. One is going to be to find an side, and then the other one's going to be to find an angle. And so if you look at your books, I want to do problem number 8 on page 351. On page 351 says, A is equal to 51, B is equal to 24, and C is equal to 31. And it says find the largest angle. Now, one thing you have to remember is the largest angle is always opposite the largest side. Why is that true? If I drew any triangle, something like this, you know opposite the longest side, this thing is going to open the furthest in terms of angles. So that's why we pick this one as the longest side, and I know the largest angle is going to be angle A. So if I want to use one of those equations on the right, it would be cosine A equals B squared plus C squared minus A squared all over 2BC. By just substituting in, you end up with this, and ultimately you want to actually solve for your angle A. So remember, you want to find the inverse of whatever that thing is, and that actually doesn't give you the reference angle, but it will give you your angle A, simply because it's finding the inverse of cosine, and it's defined in the first and second quadrant. When you do that, you're going to find that A is going to be approximately 136 degrees. Now, some students who did this before said, oh, my calculator's not doing it right. The reason why you may not be doing it correctly is because if you did this all in one go, you have to put parentheses around the top and around the bottom, because you're dividing by that whole product on the bottom. If you didn't put it, parentheses, you're going to be multiplying by these other two numbers on the bottom. So put parentheses around the top. I would do the whole thing at once. Next, I'd like to do one more problem, and that problem is going to be number 24, which is a bearing and a distance. And number 24, it reads, and I'm just going to draw it as I read it because, again, you need a real big, nice, clear drawing to help you solve these and accurate. Two ships leave the harbor at the same time. One ship is traveling at 14 miles per hour on a course with the bearing of, bearing tells me, drop the north-south line, south 13 degrees west. Everything clearly labeled here. While the other is traveling at 12 miles per hour on a course of a bearing of north 75 degrees east. Here is 90, so 75 has to be up here. Again, from the north side, coming down clockwise. And that is going to be 12 miles per hour. And then I go, that's everything that it says. Then I go to the question, how far apart are they after 3 hours? How far apart are they after 3 hours? Which means, what is my distance, x? But it's talking about distance. So I have to remember, this is a rate. I need to change it in terms of distance. How do you change rate to distance? Two ways to think about it. Rate times time equals distance, or you can think about it as the rate is miles per hour, write it that way, times hours is going to give you miles. So either way, you can think about that. So I just need to multiply this by 3 hours and this by 3 hours. And so that's 42 miles and 36 miles. And that's all good. So now what I want to do is go ahead and write down my law of cosines. So x squared equals 42 squared plus 36 squared minus that small part, which is going to be 2 times 42 times 36 times the cosine of the opposite angle. Cosine of the opposite angle, it's the supplement of 75 there, so 105 degrees, which means cosine of 105 degrees. Now, don't forget on this, because you don't want to have to do all that work and then make a simple error at the end. Oh, yeah, sorry. Thank you very much. 118 degrees. Thank you. You don't want to go through this whole thing and make an error. Well, that would have been an error. But another error, which would be to go ahead and compute this and then just say that's what your x is. Remember, you're solving for x squared here, so you really have to take the square root of both sides, and so you just don't want to forget about taking the square root of both sides. All right, there's an example on the finding a side, example on finding an angle, and the assignment's going to be a little bit longer today. And then we have one more section to go through, 2 more sections to go through before we're done with this chapter. And the chapter test on this one will be on Monday.